Okay, so you know that scene in Terminator 2? You know where the T-1000 just like morphs right through those metal bars? It's
Yeah.
pretty wild. Well, get ready because we're diving deep into the science of living metals today. And you're about to discover a material. It's so bizarre. It seems like it's straight out of science fiction. Liquid metal that acts like it's alive.
Yeah, it really makes you rethink, like, how we even define living versus, non-living. This isn't just some new kind of metal. It actually behaves like a simple organism. It exhibits some really remarkable properties.
So let's start with the basics. We all know that metals are like solid
Mm,
and rigid,
right.
but this one breaks all the rules. Imagine something that's liquid at room temperature, like mercury, but it can hold its shape and even, like, remember its original form.
And here's where things get really interesting. Unlike a passive liquid, like water, this metal actually moves on its own, autonomously, almost as if it has a mind of its own.
Like it's making decisions.
Right.
Scientists have even seen this metal solving mazes in the lab.
Exactly. And it all comes down to a clever trick with chemistry. Think about how soap breaks up oil and water. Well, this liquid metal uses similar chemical gradients on its surface to propel itself through liquids. Essentially, it's creating its own tiny motor using chemistry.
So it's not plugged into anything. No batteries, no external power source.
Mhm.
It's generating its own energy just by interacting with its environment. That's incredible. What else can this metal do?
Well, imagine being able to mold and reshape metal with just a tiny jolt of electricity, less than what you'd get from an AA battery. This material can stretch, form perfect spheres, create wires. It can even split itself into separate droplets.
It's like a microscopic sculptor working with liquid metal. What's fascinating is that it's incredibly precise. You can control its shape with pinpoint accuracy.
And that controllability, it just opens up a world of possibilities. We're talking about medical devices that can navigate through the bloodstream, self-repairing circuits, even robots that can adapt to any environment.
It's almost like we're blurring the lines between the mechanical and the biological. So how did scientists even discover something this revolutionary?
Well, it's a fascinating story. It starts with this simple question. What if we could create materials that behave more like living organisms? Researchers have been exploring this idea for decades, experimenting with different materials and techniques.
And they really struck gold with this liquid metal.
hmm
What were some of the key breakthroughs that led to this discovery?
One of the biggest challenges was finding a material that could be liquid
Yeah.
at room temperature. While still having all those properties they were looking for, it was a bit of a Goldilocks scenario. They needed something that was just right.
So it wasn't just melting down some existing metal.
No, not at all. They had to experiment with different alloys and combinations of elements until they found a formula that showed those properties.
And once they had that right material, how did they figure out how to control its movement and shape?
A lot of that was trial and error, observing how the metal responded to different stimuli, like electrical currents and chemical gradients. They had to learn how to speak the language of this new material.
It's almost like they were training a microscopic pet. So let's talk about some of the potential applications of this technology. We've already touched on medical devices and self-repairing circuits, but what other areas are researchers excited about?
One area that has a lot of potential is robotics. Imagine robots that can flow like water, adapting to any environment, squeezing through tight spaces.
Like those liquid robots from Terminator 2. But this time it's science fact, not science fiction.
Exactly, and because this metal is so strong and durable, these robots could be used for all sorts of things. Search and rescue operations, exploring hazardous environments.
They could even be used for things like plumbing or electrical work,
Mhm.
navigating through pipes and wires to make repairs.
Precisely. The possibilities are really endless. And because this material is self-healing, these robots could actually repair themselves if they were damaged, making them incredibly resilient.
Speaking of self-healing, let's explore how this metal could revolutionize infrastructure. I mean, we've all seen the headlines about crumbling bridges and aging pipelines. Could this technology offer a solution?
Absolutely. Imagine bridges that can strengthen themselves under stress, roads that heal their own cracks, pipelines that can detect and seal leaks automatically.
It sounds like we're talking about self-healing cities, buildings that are more like living organisms than static structures.
That's the idea. And it doesn't stop there. Imagine cars that can change their shape to improve aerodynamics or to navigate tight spaces, clothing that adjusts to temperature changes and repairs its own tiers, even furniture that reconfigures itself to fit different needs.
This is seriously mind-blowing. It sounds like we're on the verge of a technological revolution. one where the materials we use become more responsive and adaptive, blurring the lines between the natural and the artificial.
Exactly. And it raises some fascinating questions about the future of design and manufacturing. What happens when the materials we work with can essentially think for themselves?
It's almost like we're entering a new era of collaboration, where humans and materials are working together to create truly innovative and sustainable solutions. But what about the potential downsides? Are there any risks or ethical concerns we should be considering?
Yeah, it's definitely exciting. But like with any powerful technology, there are always potential downsides. We need to be cautious and consider, the ethical implications before this becomes widespread.
Oh, you're absolutely right. One concern is control. We need to make sure that we can reliably control these materials and prevent, unintended consequences. What happens if, like, a microscopic surgeon malfunctions inside a patient or a self-repairing circuit in a critical system just goes haywire?
Those are some serious questions, and it really highlights the need for rigorous testing and safety protocols. What are some other potential risks?
Another concern is the environmental impact. This liquid metal is biodegradable, but we need to carefully study its long-term effects on ecosystems. We don't want to solve one problem only to create another. That makes sense. We need to make sure that the benefits of this technology outweigh any potential harm to the environment. It sounds like there's still a lot of research to be done before we see widespread adoption of living metals.
Definitely. It's crucial to proceed with caution and ensure, responsible development every step of the way. But despite these challenges, the potential of this technology is truly transformative.
It is. We've talked about practical applications, like in medicine and infrastructure. But I want to go back to something you mentioned earlier, the blurring of lines between living and non-living matter. What are the philosophical implications of that?
That's where things get really interesting. This technology forces us to kind of re-examine our definition of life. If a piece of metal can exhibit behaviors that we typically associate with living organisms, what does that say about the nature of consciousness or intelligence?
Could we eventually create artificial intelligence that's basically indistinguishable from human intelligence?
Right.
Or even surpasses it? It's a thought-provoking question.
Absolutely. And it goes beyond just intelligence. This technology could change our whole relationship with the material world. What happens when the objects around us can sense, respond, and even adapt to our needs? It challenges our traditional understanding of what's natural versus artificial.
It's almost like we're entering a new era of animism, where we see the world around us, as imbued with a kind of life force, even in inanimate objects.
It's a fascinating perspective, and it really highlights the need for open and honest conversations about the future we're creating. This isn't just about technological advancement. It's about shaping a world where technology and nature can coexist and even complement each other.
Well, I think we've given our listeners a lot to think about today, from microscopic surgeons to self-healing cities, from the practical to the philosophical. Living metals are pushing the boundaries of what we thought was even possible.
Yeah, it's a truly revolutionary field with the potential to reshape our world in some really profound ways. As we move forward, it's up to all of us to engage in thoughtful discussions about the ethical implications and make sure that this technology is used responsibly for the benefit of humanity and the planet.
And that's it for this deep dive into living metals. I hope you enjoyed it. This is a topic that's sure to keep evolving in the coming years, so stay tuned for more updates and insights as this incredible field unfolds. Thanks for joining us.